Hello, today I have a little science experiment for you. Ever since that steam pipe in New York City caused a 30-foot wide hole in the street, I've always been fascinated by the water hammer effect in cavitations. The water hammer effect occurs when water slams into something. Since water is not compressible, it can't go anywhere when something gets in its way. And one of the things it does is it forms something called a cavitation. And a cavitation is nothing but a negative pressure bubble. And since nature opposes vacuums and it has all the pressure of the atmosphere pushing on it, it slams shut several times the speed of sound. And it sends out a massive shock wave that rattles the pipes. And you can hear it in your house sometimes when you turn off a faucet. And there's also a party trick out there where if you take a glass bottle, fill it partially with water, and then you hit the top of it with the soft part of your hand, it causes the cavitation which blows out the bottom of the glass bottle. I'll see if I can find a few links and I'll stick them in the video description for you. Alright, here's the experiment. I can't actually do this entire experiment today because I do not have a vacuum pump on hand, and I need a vacuum pump to do this correctly. What I'm going to do is I'm going to fill this 5-gallon bucket full of water. And right here I have a piece of PVC pipe that's about 4 inches in diameter. What I did was I sealed the ends off with foil and duct tape. And then what I'm going to do is take this and place it in the bucket about 6 inches off the bottom. And then I'm going to suck all the air out of it. Yeah, you suck all the air out of it through that hole in the side right there. And then what I'm going to do is puncture the top layer of foil. Yeah, when I puncture the top layer of foil, the water is going to go shooting into the pipe, and it's going to crash into the water on the other side. And I'm hoping when the water crashes together, it'll cause a huge cavitation. And then that cavitation is going to slam shut several times the speed of sound, and then it's going to slam the walls of the bucket with the shock wave from it. I think you people that are into science can see where I'm getting this from. Alright, I'm going to talk about this steam pipe in New York City a little bit more. I believe it was an 8-inch steam pipe. What happened was, high-pressure steam slammed into standing water that was in the pipe, and it caused the cavitation. And when the cavitation slammed shut, it caused a huge shock wave that caused the pipe to burst wide open and blow a 30-foot wide hole in the street. And it caused such a shock in the area that witnesses actually said they thought the Chrysler building had collapsed. So really, this is a 4-inch pipe. So really, you can see that that's not messing around, and that pipe was only 4 inches bigger than what I got here. So you can see where I'm getting this from. I tell you, I would not do this on a cement floor or a patio, because it'd probably break it. Could you imagine a 2-foot pipe in a swimming pool, what that would do? That might be really nasty. I would not want to be in the water and do that. Well, thanks for watching. Please subscribe and stay tuned. The reason my bucket says balls on it is because it was full golf balls when I was playing driving range.